Good evening, class. I welcome you guys to this our first lesson in the teaching series, um, algorithm and flowcharts. We shall be looking at different topics from problem solving to what exactly do we understand by algorithms, and from there we shall be proceeding to different steps in writing an algorithm. Then we shall be looking at flowcharts and problem solving. Now, to begin this lecture, what is problem solving? Now, can you think of a day in your life which goes without problem solving? No. Every day, from the moment we wake up to the time we go to sleep in the night, we are always solving problems. Now, answers to this question is, of course, no. In our lives, we are bound to solve problems. It's inevitable. All these activities involve some kind of problem solving. It can be whatever activity human or machine does. For example, if you're watching the news on TV and you want to change this to a sport channel, you want to solve a problem. Now, the solution to this problem is the remote. This is a kind of problem. So, problem solving is basically the steps by which we take to solve a particular problem. That is basically what problem solving is. Which leads us to our main topic, which is algorithms and flowcharts. Algorithm can be defined as a sequence of activities to be processed for getting a desired output from a given input. Now, before our class, we had met and had given you guys the assignment to go forth and check the process of making Gary. Now, before Gary, you can have the product Gary. It goes through a process. And what is that process? Cassava is planted. Until a given time, it is harvested. So from that time of being harvested, it goes through a series of process. It goes through a series of process before we can have the end product called Gary. In English, we call it cassava flakes. So, which leads us to algorithm being what? A sequence or series of activities by which we carry out for getting a desired output. Now, there are different steps involved in writing an algorithm. Step 1, define your algorithm inputs. Many algorithms take in data to be processed, e.g., calculate the area of a triangle. Now, in this, what is area of a triangle? We said half base times height. Half base. Now, you have to have your height and your base, or we call it width, before you could what? Calculate a triangle. Define your algorithm inputs. Know exactly what you want to work with. That's the first step in writing an algorithm. Step 2, define the variables. Algorithm variables allow you to use it for more than one place. We can define two variables for rectangle height and rectangular width. We should use meaningful variables, e.g., height and width, as variables. After that, step 3, outline the algorithm operations. This involves what? Use of input variables for computational purpose, e.g., find the area of a rectangle as we are using. That is, we have to multiply your height and your width and store them in a variable called area. Now the multiplication of the height and the width gives us what we call area. Now, so that is what outline the algorithm's operations. Outline the steps in totality to give you your required output. Step 4. Outputs results of your algorithm operations. In case of this area of rectangle we're talking about, you store your results in variable called area. Now, if the input variable describes a rectangle with height of 2 and width of 3, then the output will be length times breadth. Height times width will give us what? 6. In the case of a triangle, it will be half base times height. So, linking this to our day-to-day activities, now I said go and ask on the process of making garri. How do we make garri? The process, first step, you start. When you start, garri is being planted for a number of days, after which welcome back, guys. So the process of making garri, starting that process. Now we said garri is partially galvanized, that is by toasting. Now, what are the processes involved in making garri? You select the root from a lot of processes. That is, from the time of harvesting, you select the ones that are good. Now, this is a process. We can liken this to what? An algorithm. Now, this is an example. From the first process of selecting the garri, the cassava from its roots, now we have identified the good ones that we can use. The next step is what? To peel. After peeling, we wash cassava roots. After peel, we wash the cassava. Now we grate them into mush. Now we'll be having a video of the actual process of making this, which I will post for the class later on. After which we dewater and ferment into wet cake. Then after which we sieve into grits and roast grits into garri. Bagging and storing, that's the next step. Then we end. Now all these processes being carried out is what we call an algorithm. After that, this then leads us towards flowcharts. Now, what is flowchart? Flowchart is a diagrammatic or graphical representation of sequence of steps to solve a problem. It is simply what? A diagrammatic representation of the algorithmic steps. Now, to draw a flowchart, we use what? Symbols. That is why it is called pictorial representation. Now, flowcharts, the design of flowcharts can be back to goes back to 1945, which was designed by John von Neumann. Now, unlike an algorithm, flowchart uses different symbols to design a solution to a problem. Like we've said, it is another commonly used programming tool. By looking at a flowchart stone, can understand the operation and sequence of operations performed in a system. Flowchart is often considered a blueprint of a design used in solving a particular problem. Now, what are the advantages of flowcharts? One, flowchart is an excellent way of communicating the logic of a program. Easy and efficient to analyze different problems. During program development cycle, the flowchart plays the role of a blueprint, which makes program development easier. That is the process of program development easier. Now, after which, another advantage is after successful development of a program, it needs continuous timely maintenance during the course of its operation. Then the flowchart makes program or system maintenance easier. One final advantage is it is easy to convert the flowchart into any programming language code. And we have various programming language code which will be posted, has been posted on our platform where you see them. Yeah, so that will be all for now. So what have we learned so far for this lesson? We've learned about problem solving. Now, and we say that every day of our life we solve problems. From the time we woke up, you have to solve a problem of going to school, whereby you have to bathe, brush your teeth, wear your clean uniform, eat, do your morning chores, take your bath, leave your house, go out, board a bike or you trek, or you get a car before you get to your house. That is what we mean by problem solving. And we said, what is algorithm? We said algorithm can be defined as a sequence or process by which activities are being carried out. That is, it can be defined as a sequence of activities we carry out for a given solution to be met. It is the process, step-by-step way of solving a problem. From there, we liken this to the process of making garri. Yes, we liken it to the process of making garri, whereby we start from actually identifying the garri from its root. We separate. After that, we select healthy root, then we peel, wash. All these processes of making garri. And we say, what is flowchart? Flowchart is a diagrammatic or pictorial representation of the processes involved in solving a problem. Our assignment will be given to the class. Thank you and see you next time.